it was very fascinating because they did an experiment with an electrical circuit. This is a circuit that is incredibly small, a fraction of the thickness of a hair, but compared to quantum size, it is massive. It's made out of trillions of quantum particles on top of each other. So when it gets to quantum scales, it is macroscopic by all means and purposes. But they extremely cooled this down through cryogenic technologies, and they put it in a superconducting state. And using this circuit, they could show that electrons can do quantum tunneling in these circuits. There are places that the electron is not supposed to be able to go through, but because of the properties of the circuit, and because it's so incredibly cooled down, that the entire circuit starts behaving like a quantum entity. It creates and maintains quantum coherence. This was amazing for us because for the first time we could bring out quantum from an atom, from an electron, from a photon into an object that we could build, because a circuit is a chip, it's on a chip. That also itself is significantly important. This is the second part of that sentence, the quantization on an electrical circuit, because later, very soon, the use case and application of that was for quantum computing. Those circuits, they became superconducting quantum computers. They became the building blocks for us to now build quantum computers. But because of the work of these three scientists, we learned that we can actually make these things happen on an electrical circuit. Now, this is a very special circuit. It has to be in superconducting mode. So not only specific materials and specific constructions, but it's also heavily cooled down, millions of times cooler than the outer space temperatures. Only then the circuit starts behaving like a quantum particle, like a qubit. But then we can put a lot of these on a chip. So we can actually start thinking about scaling down, scaling up quantum computers and build the next generation of computers that could solve a lot of our problems. And that's why these people now are winning the Nobel Prize physics, because what they discovered, the possibility of doing quantum in larger scales, is becoming now the foundation of a new paradigm for computing. And that's fucking amazing.